This is Mr. Martin. These are the video notes for math analysis for section 4.5. We're going to be looking at graphs of the sine and the cosine functions. You've probably seen these before, so hopefully there's not too much new here. Um, you can see in the pictures here we've got the basic y equals sine x on the left and the basic y equals cosine x on the right. And a couple things that I want to point out here is that you can see this highlighted part here for the sine curve that goes between 0 and 2 pi. That's one cycle or one period for the sine curve. And then when we look over at the cosine curve, we could see the bold part that goes between 0 and 2 pi. That's one cycle or one period over there as well. And then just to point out some other important points, I've got an intercept here, an intercept at pi, and an intercept at 2 pi. And then I've got a maximum value up here at pi over 2, a minimum value here at 3 pi over 2. And if you think about these 5 spots in relation to the unit circle, the sine really is the y-coordinate as we go around the unit circle. So at 0 radians, our y-coordinate is 0. At pi over 2 radians, our y-coordinate is 1. That's why we're up here. And then over at pi again, the y-coordinate is 0. Over at 3 pi over 2, down on the bottom of the circle, the y-coordinate is negative 1. That's why we're down there at negative 1. And then once we come back to the beginning, 2 pi, the y-coordinate again is 0. So if we look at these important spots here, down at the bottom here, back at an intercept, and then back at a maximum. So if we look at these 5 points again with respect to the unit circle, at 0 radians, our cosine, our x-coordinate is 1. And then up at pi over 2 on the unit circle, our cosine is 0. That's why we have an intercept here at 0. And then at pi, our x-coordinate is negative 1. That's why we're down here at negative 1. And then at pi over 2, 3 pi over 2, we're back at 0. And then at 2 pi, back at the beginning, our x-coordinate again is 1. So let's go ahead and take a look at our basic form of the equation for sine and cosine. You see we've got y is equal to d plus a sine quantity bx minus c. And then we just substitute in cosine when we're going to be graphing cosine. And then the important things about this graph that we're going to be talking about are amplitude, period, phase shift, or horizontal translation. You may have seen it. Vertical translation, and then we'll also talk about the distance between key points. So the amplitude is simply going to be the absolute value of a. So whatever this value of a is over here, the absolute value of a will tell us the amplitude. And that's simply half the distance between a max and min value. Okay, so if we go up here, we can see that the amplitude, the highest value is 1, the lowest value is negative 1, so the distance between those would be 2, so half of that distance would be 1, so the amplitude for this graph is 1. Same thing over here for the cosine graph, amplitude is 1. So then moving on to the period. The period is calculated by taking 2 pi and dividing it by b. And this is the length of one cycle. Again, if we come back up here, we can see the yellow highlighted parts for sine and cosine are what one period looks like. Now, remember that the sine curve, the period will always look like this kind of sideways S shape, sideways backwards S shape. And the cosine, one period, will always look like, I like to call it a fruit bowl. It kind of looks like this. but it will always look like this shape. So it may be stretched out a little longer, it may be pulled a little taller or squished a little bit shorter, um, but the periods for sine and cosine will always look like these. All right, then moving on to the phase shift or the horizontal translation. We calculate this by taking C and dividing it by B, and then this just shifts the curve left or right. And then the vertical translation, that's calculated by the value of D. If D is positive, it's going to go up. If D is negative, it's going to go down. This is shifts the curve up or down. Okay, then distance between key points, the way we calculate this is we're going to take the period and we're going to divide it into 4 equal parts. And this is going to tell you when max, min, and intercepts occur. And that's going to be an important number for us when we're graphing. Okay, so if we look again at these two standard graphs, we have one period of y equals sine x, we have one period of y equals cosine x. You can see the values for A, B, C, and D here. For A, it's 1. For B, it's also 1. And then C is 0, and D is 0. That's a C, and that's a 0. Okay, and then we have the same thing over here. A is 1, B is 1, C is 0, D is 0. Okay, and we can see it goes to 2 pi. Over here, it also goes to 2 pi. This is 2 pi over here. Again, you have this backwards S shape, and over here you have this fruit bowl shape. So let's go ahead and take a look at some examples. We're going to graph 2 periods of each. So what I'm going to do first is I'm going to find A, B, C, and D. So for this I can see that A is equal to a half, B is equal to 1, and then C and D are both 0. And then once I have A, B, C, and D, I can find my amplitude, which is just the absolute value of A, so that's going to be a half. I can find my period, that's 2 pi divided by B, so that's 2 pi over 1, which is just 2 pi. And I can find my, I'm going to call it PS for phase shift, and that's C over B. So C is 0 and B is 1, so 0 over 1 is just 0. And then my vertical shift, or vertical translation, I'll call it vertical shift, that's based on D, so that's also 0. And then the last thing that I need to find is distance between key points, which from now on I'll just call it D, B, K, P's, and that's our period divided by 4. So that's 2 pi divided by 4, which is pi over 2. All right, and that's going to be an important number for us. So once we have this, we want to make a little chart of a few values. And once you get the hang of the chart, you may only have to finish 2 or 3 values in the chart till you get the hang of it. But we'll go ahead and we'll do all 5 values. We're going to do 5 values for the chart. So I've got x, And then I've got y equals 1/2 cosine x. And then in our chart, we always want to start with the value of the phase shift, because if our graph is shifted to the left or to the right, that's going to change our key points. So in this case, since our phase shift is at 0, we're going to start our chart at 0, and then we use our distance between key points to tell us how far away the next key point will be. So if this is a maximum or a minimum or an intercept, pi over 2 away, that distance between key points, will tell us when the next maximum, minimum, or intercept will be. So I'm just going to add pi over 2 to this. So I'm going to add pi over 2. Then I'm going to add pi over 2 again. So pi over 2 plus pi over 2 is 2 pi over 2. So that's pi. And then I'm going to add pi over 2 again. So that's 3 pi over 2. And then we need 5 values in the chart to complete one cycle. And that'll be 2 pi. So then I'm going to go ahead and I'm going to plug each of these in. So I've got 1/2 times the cosine of 0. So that's 1/2 times 1, because the x coordinate at 0 is 1. So that gives me a half. So now I have an ordered pair that's 0 and a half. And then I'm going to plug in pi over 2, cosine pi over 2. So that's a half times 0, which is 0. I have a half times the cosine of pi. Over at pi, the cosine is -1, so I have negative a half. Then I have a half times the cosine of 3 pi over 2. So that's a half times 0 again, which is 0. And maybe you can see a pattern here. So we have a half times the cosine of 2 pi, which is a half times 1 again, or a half. So I've got these 5 ordered pairs. I got 0, a half, pi over 2, 0, pi, negative a half, 3 pi over 2, 0, and 2 pi a half. And I'm going to come over here. I'm going to label my axes. I'm not going to draw it to scale. So I'm going to make this a half. I'm going to make this negative a half. And then I'm going to make each one of these marks a pi over 2. So this would be pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. Let's go 2 more. 7 pi over 2, and then 4 pi. Okay, and let's go ahead and graph our points. So I've got 0, a half. I've got pi over 2, 0, pi, negative a half, 3 pi over 2, 0, and 2 pi is back up to a half. So here's our points. Be really careful when you draw in your curve, because if it looks too straight and V-shaped, it's not correct. So here's one period. So now we just want to repeat this for a second period. So if we're up here at 2 pi and a half, our next value following the pattern would be at 0, and then at 3 pi we're going to have negative a half. At 7 pi over 2 we'll have 0 again, and then at 4 pi we'll have a half again. And then we just draw in a nice smooth curve. And there you have 2 periods of y equals 1/2 cosine x. So I'm going to end this video here. Move on to the next video to see the worked out solutions for examples 2, 3, and 4. As usual, make sure you write down any questions that you have in the margin so you can ask me in class.